Alright, welcome back. In this video, we're going to go over glycolysis steps 4 and 5. If you have not watched my last video, 1, 2, and 3, I highly suggest you watch it because you're going to probably be lost if you're watching this one first. So yes, in the last video, step 3, we went over that we created a molecule called fructose 1,6-bisphosphate. Now, if you did watch the last video, you're probably a little confused. You're probably like, wait a second, this molecule looks completely different than what you wrote. That is actually true. So this is what was in the last video. Fructose 1,6-bisphosphate as a ring. This is actually the exact same thing as I wrote in this video. This molecule right here. All I did is I unwound it. I did not draw it in a ring. I drew it straight down from top to bottom. It's still the exact same molecule. We had the exact same stuff on it. I just wrote it differently. Now, the reason I wrote it differently is because it's going to make it so much easier from here going on forward. It'll be really easy to recognize what is happening to the molecule when you use different enzymes. So let's get started. So now we have fructose 1,6-bisphosphate. We're going to take an enzyme called aldolase. And what aldolase is going to do is going to split this this molecule in half. Kacha! Like karate chop it. The first molecule it's going to create, the top half, is dihydroxyacetone phosphate. The bottom molecule we create is glyceraldehyde 3-phosphate. So aldolase, well, what is happening here? It's actually in the name, the enzyme name. Aldolase. Ald means aldehyde. Ol, O-L, means alcohol. So what we're doing here is we're creating an aldehyde and an alcohol. The top molecule, dihydroxyacetone phosphate, is the alcohol. The glyceraldehyde 3-phosphate, it's in the name, is an aldehyde. Now, we have a delta G value of positive 22.8 kilojoules per mole. This is taking a lot of energy to actually run. So it's a rapid consumption of the products actually pulls this forward. And we're going to get into that in the next step. So once again, the aldolase splits the molecule into an alcohol and an aldehyde. And the reason for this is we need 2 triose sugars for the energy payoff phase, which is step 6 onwards. So a triose is just another fancy way of saying a 3-carbon molecule or a 3-carbon sugar. Now I want you to note the alcohol that we just created in this reaction is useless. And I'll tell you why in a second. Now the glyceraldehyde we created, the glyceraldehyde 3-phosphate, it's safe. This is the molecule that we actually want. It's safe. We're not going to touch it again until step 6. So let's go over what's happening to the molecule. So here we have fructose 1,6-bisphosphate. This enzyme is going to basically karate chop it right in half. And we're going to create 2 3-carbon molecules here. Here's one. And then the other 3 carbon molecules on the bottom. So we created 2 3-carbon molecules. It's a mouthful. So here's what we did. The top half. So we karate chopped it right here. All we did is we moved this molecule here. It's the exact same thing. We just rewrote it there. Just karate chopping it. But it looks different because what we did is, since we cut this bond here, this carbon has 1 bond, 2 bonds, 3 bonds. Carbon must have 4 bonds. So hydrogen's going to basically take its place. So that's why we have a CH2 here instead of a CH. Because you're probably, wait a second. Well, This is the same. This is all the same. And then, well, what about the hydrogen here? So we have one hydrogen. Well, the other one's going to come because we split this bond right here. And carbon must have 4 bonds. So basically, just add a hydrogen. That's all we're doing, is add a hydrogen. Now for the bottom molecule, well, once again, we cut it here. So we're taking care of this part here now. And all we did is we made this carbon and oxygen a double bond. And we removed this hydrogen. That's all we did. Is we just created a double bond between the carbon and the oxygen, and we removed the hydrogen. And why it looks different is because I just wrote the double bonded oxygen carbon here on the left-hand side, pointing this way. It's still the same thing. So that's all we did. It looks complicated. It does. I'm not going to lie. It does look complicated, but it's really not when you really break it down like this. All we did is just created a double bond between carbon and oxygen and remove the hydrogen. That's it. And here we just added a hydrogen here. And we, of course, broke up the molecule. The hardest part of this is actually the name. Probably dihydroxyacetone phosphate and glyceraldehyde 3-phosphate. Remembering those names is probably the hardest part of this step. Okay. Now, like I said before, the alcohol we just created, this alcohol, is useless. Our goal is actually to create 2 aldehyde molecules. 2 glyceraldehyde 3-phosphate molecules. But our body's not perfect. We don't have an enzyme to actually do this. So our body compromises. It's like, okay, let's do this. Let's actually make an aldehyde and an alcohol, and then later, in the next step, take that alcohol and then transform that into an aldehyde. So that's what we did. So step 5 is we just took the alcohol from the last step and we're converting it into a glyceraldehyde 3-phosphate. Because that's our end goal here. We're trying to get this molecule. We can't do anything with the alcohol in our body. But we don't have an enzyme that actually makes 2 aldehydes. So we have to make an alcohol and an aldehyde and take that alcohol in the next step and transform that into an aldehyde. So that's all we're doing. So the dihydroxyacetone phosphate, we're going to use an enzyme called triose phosphate isomerase. And we're going to create glyceraldehyde 3-phosphate. It's the exact same molecule as in the last step. This. Same thing. So by the end of step 5, we're going to have 2 glyceraldehyde 3-phosphates. One from step 5, from the alcohol turning into the aldehyde, and the one here from the fructose 1,6-bisphosphate turning into a glyceraldehyde. The delta G value is 4.4 kilojoules per mole, and the rapid consumption of the aldehyde pushes it forward in step 6. So the triose phosphate isomerase turns the alcohol we just made in the last step into the second aldehyde, identical to the last step. So if you know step 4, you already know step 5, because the product of step 5 is literally the same thing as step 4. It's the same molecule. Now, if you want to understand how it actually transforms, all we're doing here is we're moving this double bonded carbon oxygen to the top and moving this down below. So now here in glyceraldehyde 3-phosphate, the carbon double bonded oxygen is now on the top with an aldehyde here, and the alcohol is right here. That's it. Ta-da! And the purpose of this is to help regulate, is for regulation down the road. Not really important. But the whole point of step 5 is to create the second glyceraldehyde 3-phosphate. That's it. And yeah, if you found this video helpful, please like and subscribe. Until next time, later.